The electron volt. We often use different units for different purposes. You might, for instance, measure your journey to school in miles, the length of your classroom in meters, the diameter of your pencil in millimeters, and the distance to a star in light years. Just a few examples of different units used for distance. In general, we choose the units to give relatively small numbers. We can deal with 467, it's an imaginable number, but find it difficult to imagine 4.67 times 10 to the 22, or 4.67 times 10 to the minus 15, for example. At GCSE you probably met the kilowatt hour, used because the joule was too small a unit of energy, the kilowatt hour being a much bigger unit of energy. When dealing with particles, the joule is often too large a unit of energy, and so the electron volt is used instead. But what exactly is an electron volt, and how does it come about? Well, here we have two plates with a potential difference or voltage of 1 volt between them. If I place an electron here, it will accelerate towards the positive plate like this, as unlike charges attract and the electron carries a negative charge. So here, just before it hit the plate, it would have had kinetic energy. It was moving. Therefore here it must have had electric potential energy, given by energy E is equal to charge Q times potential difference V. Now Q in this case is just the charge on the electron. I've missed off the negative sign here, as it's just the magnitude we're interested in, of 1.6 times 10 to the minus 19 coulombs. V, the potential difference, is just 1 volt in this case. So, the energy is given by 1.6 times 10 to the minus 19 coulombs times 1 volt, which gives 1.6 times 10 to the minus 19 joules. One of those hard to imagine numbers. But this amount of energy is 1 electron volt, written like this with a lowercase e and uppercase v. It's now easy to imagine. In going from electron volts to joules, we simply multiply by the charge on the electron, 1.6 times 10 to the minus 19. This gives us a smaller number. If you're going from electron volts to joules, you're going to end up with a smaller number than you started with. In going from joules to electron volts, we need to divide by 1.6 times 10 to the minus 19 to give a larger number. 1 joule is an awful lot of electron volts. It's worth just looking at your answer to see whether it makes sense. Don't forget that for all calculations, the best way is to convert all your data into SI units at the start, and, if necessary, convert your answer back into the desired units at the end.